Alright, time for some algebra. Now in this video I'm going to show you some very simple rules that will make answering questions like this really straightforward. Now in these type of questions we're always looking for the value of some unknown variable. That variable is usually x, but it could be y, it could be n, it could be anything at all. But usually we're trying to find the value of x. Now in order to do that we need to take each one of these equations and manipulate it and rearrange it to get the unknown variable on its own. So let's see how we do that with 4 simple rules that will make answering these questions really straightforward. Okay, so we're going to start off with a much simpler equation to begin with. So in this example, we've got find x, where x plus 2 is equal to 5. Now, the wrong way to think of this question is like this, and believe it or not, a student actually did this on a standardized test. The question said find x, and he said here it is, and he put an arrow pointing to it and actually wrote here it is. He must have come out of that test thinking, wow, I nailed that. That was so easy. But clearly that's the wrong way to think about this, so let's think about the right way of thinking about equations. So here's a top tip. Think of an equation as a set of scales. Now I'm going to draw a set of scales underneath there, and we'll illustrate what's going on. Now the equal sign, I always think of that as the balance point of the equation. So it separates the left-hand side from the right-hand side. And in our equation here, we've got x plus 2 on the left and 5 on the right. Now I want to get the x on its own, so how do I get rid of that plus 2? The easy way is to take 2 away from the left-hand side. But when I do that, okay, I get my x on its own, but the equation is no longer balanced. So in order to keep the equation balanced, I need to do the same things to the other side. So if I take 2 away from the right-hand side as well, the equation now becomes balanced again. So on the left-hand side, I had the 2 and the minus 2 cancel to leave me with just x. And on the right-hand side, I have 5 take away 2, which gives me 3. And hopefully we can see there that our answer is 3. Now that was a simple example, but the same idea works very well on much harder examples as well. So rule number 1 is always do the same thing to both sides of the equation. Okay, let's have a look at rule number 2. To remove an operation, we simply apply its inverse. Now you might be thinking, hang on a minute, what's all this stuff about operations and inverses? What does all that mean? But it's actually very straightforward. An operation in math is simply adding, subtracting, multiplying, or dividing. And the inverse of each one of those is very straightforward as well. The inverse of adding is subtracting, and the inverse of dividing is multiplying. So let's have a look at a couple of examples to make this really straightforward. So to remove an addition, we simply subtract from both sides of the equation. Let's have a look at an example. If I've got x plus 9 is equal to 21, and I'm trying to get rid of that plus 9, to get rid of an add 9, I subtract 9. I've got to do it to both sides of the equation because of rule number 1. So when I take 9 away from both sides of the equation there, we can see those 9's cancel. That leaves me with x on the left-hand side, and 21 take away 9 gives me 12. So I have x equals 12 as my answer. So to remove an addition, we subtract from both sides of the equation. Now let's have a look at B. So to remove a subtraction, we simply add. So if we have a look at an example there, we have x minus 13 is equal to 23. I want to get rid of that subtract 13, so I'm going to add 13 to both sides. Those 13's now cancel, leaving me with x is equal to 36. So to remove a subtraction, we simply add to both sides of the equation. Not surprisingly, to remove a multiplication, we divide. So if I have, for example, 5x equals 55, I want to get rid of that multiply by 5 to get the x on its own. So I'm going to divide both sides of the equation by 5. Those 5's now cancel. That leaves me with x on its own. And on the other side, I have 55 divided by 5, which is 11. So to remove a multiplication, we divide both sides of the equation. And finally, to remove a division, we simply multiply both sides of the equation. So in my example here, I have x divided by 4 equals 7. To get rid of that divide by 4, I'm going to multiply both sides of the equation by 4. Now, on the left-hand side, I have a fraction. I have x over 4. So instead of just multiplying by 4, I'm actually going to multiply by 4 over 1. Now, it's exactly the same thing. 4 divided by 1 is 4, but it just makes the multiplication of fractions much easier, as you'll see in a minute. On the right-hand side, I can just say multiply by 4. So let's see how this makes things simpler. those two 4's there on the left-hand side now cancel. So that leaves me with x over 1 or x. And on the other side, I have 7 times 4 is 28. So my answer is simply x is equal to 28. Okay, so rule number 2, to remove an operation, we simply apply its inverse to both sides of the equation. So rule number 3, now sometimes we have a question that looks pretty nasty like this one right here. 3x plus 1 divided by 4 equals 7. And you might be thinking, hang on a minute, do I divide by 3 to get rid of that multiply by 3? Do I subtract 1 to get rid of that plus 1? Or do I multiply by 4 to get rid of that divide by 4? And you might not know which one of those to do first. So rule number 3 helps us to figure this one out. It says always leave the term with the x in it until last. Now, when I look at my equation here, I've got on the left-hand side, I've got a fraction. And I've got my x in the numerator right there. So I'm going to leave that numerator alone because that's the term with the x in it. So what I'm going to do is I'm going to get rid of the denominator. And in fact, our top tip here is if x is in the numerator, then multiply both sides of the equation by the denominator. So step number 1, I'm going to multiply both sides of my equation by 4. Let's see that right there. The 4's on the left-hand side cancel. That leaves me with 3x plus 1 over 1, which is just the same thing as 3x plus 1. And on the right-hand side, I have 7 times 4, which is 28. Okay, now, if you're not sure at this stage whether we divide by 3 to get rid of that multiply by 3, or subtract 1 to get rid of the plus 1, then let's apply rule number 3 again. There's the term with my x in it, so I'm leaving that alone, which means I'm going to get rid of the plus 1. So step number 2 is subtract 1 from both sides of the equation. Those 1's now cancel, and that leaves me with 3x is equal to 27. Now, how do I get rid of a multiply by 3? I simply divide both sides by 3. So step number 3, divide both sides of the equation by 3. Those 3's cancel, leaving me with x is equal to 9. Great, so rule number 3, always leave the term with the x in it until last. Okay, so before we move on to rule number 4, let's just do one more example of number 3, just so we get the hang of it. Now, in this example, I've got 3/4 of x plus 1 equals 5. So let's circle the term with the x in it. That's that entire fraction right there. So I'm going to get rid of the plus 1. How do I get rid of a plus 1? By subtracting 1 from both sides of the equation. So that's step number 1 right there. Now those 1's cancel, and that leaves me with 3/4 of x is equal to 4. Now that 4 on the right-hand side is exactly the same thing as 4 divided by 1, because anything divided by 1 is itself. Now I'm going to write in the 4 divided by 1 right there. And the reason I'm doing that is because our top tip, which we can see in the box right there, talks about multiplying both sides of the equation by a fraction. And you can see by writing 4 over 1, this is going to be a lot easier. So let's have a look at our top tip. If x is being multiplied by a fraction, get rid of it by multiplying both sides of the equation by the reciprocal. Now the reciprocal of 3/4 is 4 over 3. So I'm actually going to multiply both sides of the equation by 4 over 3. At first, that looks as if it's a little more complicated than it was a moment ago. But let's see what cancels there. Those 4's cancel. Those 3's cancel. So everything on the left-hand side is cancelled apart from x. And on the right-hand side, I simply have 4 times 4 on the top and 1 times 3 on the bottom. So I have x is equal to 16 over 3. So there's a top tip. If x is being multiplied by a fraction, to get rid of it, simply multiply both sides of the equation by the reciprocal. Okay, rule number 4 then. So rule number 4, if we have x's on both sides of the equation, get them all onto the same side. So in this example here, we've got 9x minus 5 is equal to 7x plus 35. So I want to get rid of all the x's and get them onto one side. Easiest way to do that, in step 1, let's subtract 7x from both sides. So I'm taking away 7x's from the left-hand side and the right-hand side. On the right-hand side, those 7x's cancel. On the left-hand side, I've got 9x minus 7x is 2x, take away 5, and that leaves me with 2x minus 5 equals 35. Now, the term with the x in it is the 2x, so I'm going to get rid of the subtract 5. Let's add 5 to both sides of the equation. That gives me 2x is equal to 40. Now, how do I get rid of the multiply by 2? I simply divide both sides by 2. So divided by 2 there, those 2's cancel, leaving me with x equals 20. Okay, so let's quickly summarize the 4 rules that we've just discussed. Rule number 1, always do the same thing to both sides of the equation. Rule number 2, to remove an operation, we simply apply its inverse to both sides of the equation. And for example, if we had an addition, we subtract. If we want to get rid of subtraction, we add. If we want to get rid of a multiplication, we divide. And if we want to get rid of a division, we multiply. Rule number 3, always leave the term with the x in it until last. And rule number 4, get all the x's on the same side of the equation before you begin. Okay, so now it is quiz time. Let's see if you can put these 4 rules to work answering these 4 nasty looking questions. You may want to pause the video here while you have a go at these, and then when you're ready, restart the video and I'll go through the answers with you.